Hi everyone, I am Nadia Rubayat, one of your instructors for CAC 260 Digital Logic Design. In this video, we will cover Karnaugh map, also known as K-map. K-map is another simplification method of Boolean expressions. The map is made up of squares where each square represents a mean term. For example, let's say we have two variables. So we will have four possible combinations. The first combinations give us x prime y prime for mean term 0. The second one gives us x prime y for mean term 1. The third one gives us xy prime for mean term 2. And the last one gives us xy for mean term 3. For these four combinations, we need four square boxes. The first box covers mean term 0. The second box covers mean term 1. The third box covers mean term 2. And the last one covers mean term 3. So this is how we get box 0, 1, 2, 3 with respect to the mean terms. Let's write the mean term values in the box now. From the map, we can see that in row 1, both boxes have x prime in common. Similarly, x is common in row 2. So we label row 1 as x prime and row 2 as x. Now, if we see the columns, in the first column, y prime is common and in the second column, y is common. So we label them as y prime and y respectively. So this is how a K-map looks for two variables. Now let's represent Boolean functions using K-map. For this step, we need the canonical form of the expressions. A canonical form here basically means that all the literals are present in each product term. We need canonical form of the expression so that we can find out the mean terms. For example, function f2 has three product terms in its canonical form, so we can easily find out our mean terms. The mean term for xy is 1, 1, which is 3, x prime y is 0, 1, which is 1, and x prime y prime is 0, 0, which is 0. So we put 1 in the mean term boxes 0, 1, and 3. Now let's learn how to group these ones. In order to simplify the functions, we need to create groups of all the ones present in the K-map. Big groups result in better simplification. We can group any adjacent one in group 2 to the power n. So for 4 boxes, we can make groups of 2 and 4 ones. In case of f2, firstly we make a group of box 0 and 1. After that, only one 1 is left in box 3. So we need to group that as well. So even though box 1 has already been used before, we make a group of box number 1 and 3 so that we can cover 3. Next, we assign values to these groups. We need to find out the common variables. For the first group in box 0 and 1, we have a common variable row-wise, which is x prime. If we see the columns, box 0 belongs to y prime and box 1 belongs to y, which is a mismatch. In the second group, we have a common variable y, which is column-wise. Row-wise, box 1 has x prime and box 3 has x, so they mismatch. Our final step is to add all the expressions. This is the simplified result. In the function f1, xy prime represents 1, 0, which means the mean term is 2. So we put 1 in the box of mean term 2. Since no grouping is possible here, no simplification can be done. In the next example, we can see all the boxes have 1, so we can make a group of 4 ones. In these cases, where we can group all the boxes together, the answer is always 1. Now let's see K-map structure for 3 variables. 3 variables can have 8 mean terms, 0 to 7. So we need 8 square boxes. While numbering the boxes with mean terms, in the first row we get 0, 1, 3, and 2, and in the second row we get 4, 5, 7, and 6 in this serial. Let's get the values for each mean term. In the first row, we have x prime in common, so we label it as x prime. Similarly, in the second row, we have x in common, so the second row is labeled as x. Based on the common variables, we label the first column as y prime and z prime, the second column as y prime and z, the third column as y and z, and the fourth column as y and z prime. So this is our K-map for 3 variables. Now let's focus on the grouping. We can make a highest group of 8 ones for 3 variables. Since all the boxes are grouped together, therefore our value for the group is 1. This is our answer. Next, we can make groups of 4 ones. The 4 ones must be in adjacent positions. We can also fold the corner and make those ones into groups of 4. So if we try to assign a value to this group, we see that x and x prime are not common. Y and y prime are also not common. But z prime is common for the 4 ones. So our answer is z prime. The third highest grouping is of 2 ones. Any adjacent one can be grouped together. We can fold the corners and group the corner one as well. In this case, the first group has yz in common. X and x prime is a mismatch. In the second group, x and z prime are common. Y and y prime are a mismatch. So our answer is yz plus xz prime. Now let's notice something. 2 adjacent squares can represent a term of 2 variables. 4 adjacent squares represent a term of 1 variable. And finally, 8 adjacent squares represent a term which always results in 1. So we can say in summary that if we have big groups of 1, then we can get a better simplification. So while simplifying a function, we will always try to make as big group as we can. Now we will see K-map for 4 variables. Since we have 4 variables, so we will have 16 possible combinations and 16 mean terms. So we need 16 boxes. For 4 variables, we can group our ones in group of 16, 8, 4 or 2 in order to simplify our functions. Our goal is to make big groups for the best simplification. Firstly, we will draw our K-map. So for 4 variables, we get 2 to the power 4, that means 16 possible combinations and 16 mean terms. So the numbering is like this. In the first row, we get 0, 1, 3 and 2 serially. Second row, we get 4, 5, 7, 6 serially. Next, 8 starts from the last row, that is the 4th row. So in the 4th row, we get 8, 9, 11 and 10. Lastly, 12, 13, 15 and 14 sits in the 3rd row. Now let's get the values of the mean term so that we can label our rows and columns. Just like the previous time, we will see which variables are common in which rows and columns. So what you're going to do is pause the video for a while and figure out which rows and columns get which variable. So after labeling, we get w prime x prime in the first row, w prime x in the second row, wx in the 3rd row, and wx prime in the 4th row. Column-wise, we get y prime z prime in the first column, y prime z in the second column, yz in the 3rd column, and yz prime in the 4th column. Now let's see an example. In this example, f is a function which has 4 variables, a, b, c, d. We can see here that f is not in its canonical form. So firstly, in order to get our mean term, we need to find the canonical form of f. So we multiply the missing variables with each of the terms so that we can get our canonical form. After that, we figure out our mean terms and note it down. So after noting down our mean terms, we put our ones in the mean term boxes. Here, we will have 3 groups, so we need to figure out their values. The first group is formed using the folding rules. So if we fold the K-map, we get 4 corner ones in a group. So in this group, we can see that A prime and A don't match. Similarly, C prime and C don't match. So our common variables are B prime and D prime. Again, in the second group, we use the folding rules and group our 4 ones. In that group, A and A prime don't match. Similarly, D prime and D don't match. So we get our variable as B prime, C prime. In the final group, we can see that B prime and B don't match. So our variables are A prime, C, D prime. So these are the 3 terms that we get from our groups. In the final step, we will add these terms and get our final answer. So the answer is B prime D prime plus B prime C prime plus A prime C D prime. This is our simplification result. In the previous example, we saw that when we grouped 4 ones, we got 2 literals. When we grouped 2 ones, we got 3 literals. Similarly, when we make a group of 8, we will get 1 literal, and when we make a group of 16, our result will be 1. So, as we make the bigger group, we reduce our literals or variables and get the simplified answers. So these were the basics of K-map, and we will see further examples in our example class.